Dear students, today we are going to talk about delta to y conversion, and if time permits we will get into y to delta conversion as well. So before getting into the main topic, I would like to let you know that some of the students have asked me why we should use this method. Isn't some might be thinking that series parallel conversion is more than enough for solving a circuit problem, but it isn't. Sometimes the network may be a little bit bigger, it will be more complicated. So in that case, the role of y delta conversion and delta to y conversion and y to delta conversions are needed to make the circuit simplified, to make the circuit more simpler so that we can solve it easily. So this is the formula that has been given in your book. So as you can see over here, this circuit is called a delta circuit. So as you can see, it looks like a triangle, so that's why it's called a delta. It seems like a delta or a triangle, that's why we call it a delta circuit. Beside this one we have this y circuit. This is called the y circuit. So when we convert a delta circuit to a corresponding y circuit, it looks like this. So this is nothing but a conversion. So there are, as you can see over here, there are 3 points: point A, point not point A, point 1, point 2, and point 3. When we convert this delta circuit into a corresponding y circuit, it becomes like this, and it will also have 3 points: 1, 2, and 3. And as you can see over here, we have this RA, RB, and RC. So these are the 3 resistors that we have. The same resistors are also prevailing in the Y circuit, but that is being denoted with R1, R2, and R3. So the value of this RA is not equal to R1, and value of this RB is not equal to R2, and value of this RC also is not equal to R3. So this is the thing you need to remember. And this is actually the formula. R1 is equal to so as you can see over here, R1 is actually nothing but the resistor that is being connected to point 1. It is connected to point 1 in Y circuitry. But in delta circuit, in point 1, 2 resistors are connected, and those are RB and RC, right? We have these 2 resistors, RB and RC. So that's why we have written down this RA is equal to RB multiplied by RC divided by sum or addition of all the resistors that we have, RA, RB, and RC. So this is how we write down the rest of the figures as well, rest of the equations as well for R2 and R3. So sometimes it becomes a little bit complex for the students to understand and remember this RA, RB, RC, and R1, R2, R3. So they become confused. So I would suggest you not to remember this formula at all. I will show you one worked out example, and after that you just remember this example in your head, and while solving other problems you can use the same method. You don't have to remember these equations and formulas and all that, because it will complicate the scenario. So as you can see over here, we have this delta circuit, right? This is a delta circuit, and 3 resistors are being given: 3, 5, and 7. So what happens if we try to convert this delta circuit into a corresponding Y circuit? It looks like, so let me write this down like this. We have these 3 points, right? Let's say this is 1 point, this is another point. These are the 3 points that we have, right? These 3 points we have. And when we convert this delta to a corresponding star, it looks like this, right? It should look like this. So now what should be the value of this resistor? This one. Can you tell? The value of this resistor should be So this thing, let's say this point is connected to, let's say this is point number 1, this is point number 1, this is point number 2, this is point number 3. Similarly, this is point number 1, this is point number 2, this is point number 3. So at point number 1, which resistors are connected? 3 and 5. So what we do after conversion, we multiply this 3 and 5 together. 3 multiplied by 5 divided by sum of all the resistors. 3, 5 and 7. So it will be giving us 3 plus 5 gives us 8. 8 plus 7 gives us how much? 15. So you can write one more line if you want. 3 plus 5 plus 7. So it will be giving us 15 divided by how much? Can you tell? This is how much? 5 plus 3 gives us 8. 8 plus 7 is equal to 15, right? So 15 over 15 will be giving us a resistor value of 1. What about this one? I think by now you are supposed to answer this one. So this one, this resistor is connected to point 2. If we backtrack, we see that at point 2 we have two resistors, those are 3 and 7. So the value of this resistor should be 3 multiplied by 7 divided by addition of all the resistors, that is 3, 5 and 7, like the previous one. So we have 15 over here, so we'll be having 21 divided by 15, right? What about this one? This resistor is connected to point number 3. If we backtrack, if we go to the previous figure, we see that at point 3 two resistors are connected and those are 5 and 7. So we need to multiply 5 with 7. That should be divided with the addition of all the resistors, and that is 3 plus 5 plus 7, that is 15. So finally we will be getting 45, right? Not 45, this should be 35, right? This should be 35 over 15. That is giving us how much? Can you tell? If we want to have that answer in fractions, this value would be 1.4. What about this one? What is the answer in fraction? Can you tell? This value is 2.33. So these are my final values. So the final diagram we can draw like this. So this value is nothing but 1. This value is 1.4 and this one is 2.33. Fine. This is our final answer. So as you can see, you don't have to remember the formula RA, RB, R1, R2 and R3. This complicates the scenario and sometimes this will create more doubts. So I would suggest you to go through this method. It will be more easier for you to solve it. And if you have any query, you can let me know. In the next video, we will be talking about the vice versa. We will be talking about Y to delta conversion. So see you in the next lecture. Thank you. Ready to let go. You decide if you're ever gonna